In today's lesson, we'll be learning how to solve equations with a variable on both sides. In our first example, we want to solve 3x equals x plus 4. First thing you want to do is rewrite the question. Next, we want to simplify both the left side and right side of the equation. Since there is only 3x on the left side of the equation, we're going to leave it as is. And on the right side of the equation, these are both unlike terms, so we're going to leave them as well. We want to solve for x. In other words, we want to isolate x. However, terms with x are located on both sides of the equation, which means we have to either bring all of these terms to the left side of the equation or all of these terms to the right side of the equation. I'm going to bring x to the left side of the equation. That means I'm going to have to subtract x from both sides of the equation. So 3x subtract x is 2x. X subtract x cancels out, and the positive 4 stays by itself. I want to isolate x. However, x is stuck with a multiply by 2. To get rid of this multiply by 2, we are going to divide by 2. We're going to divide both sides of the equation by 2. So these 2's cancel out, which leaves us with just x, and 4 divided by 2 is 2. Therefore, x is equal to 2. In our second example, we want to solve 2 plus 3x equals 6 plus 4x. First thing you want to do is rewrite the question. Next, you want to simplify both the left side and right side of the equation. On the left side, we have two unlike terms, so we're going to leave them as is. On the right side of the equation, we also have two unlike terms. We're also going to leave them as is. Remember, we want to solve for x. In other words, we want to isolate x. However, there are terms with x on both sides of the equation. So either we bring all of them to the left side of the equation or all of them to the right side of the equation. I'm going to bring all of them to the left side of the equation. Bring positive 4x to the left side of the equation, I'm going to have to subtract 4x from both sides of the equation. Over on the left, the 2 stays exactly the same. Positive 3x subtract 4x is negative 1x. However, you do not write the 1 in. The 6 stays exactly the same, and the 4x subtract 4x cancels out. At this point, you still want to isolate x. However, x is stuck with a positive 2 and a multiply by negative 1. You need to do the opposite of BEDMAS here. So we're going to deal with the addition and subtraction before the multiplication and division. So to get rid of the positive 2, I'm going to subtract 2 from both sides of the equation. Two subtract 2 cancels out, which leaves us with just negative x, and 6 subtract 2 is 4. X is still stuck with a multiply by negative 1, which means to get rid of it, we have to divide both sides of the equation by negative 1. So these are going to cancel out, which leaves us with just x, and 4 divided by negative 1 is negative 4. Therefore, x is equal to negative 4. In our last example, we want to solve and check negative 3 plus 2x equals 3x minus 4. What you want to do is rewrite the equation. Next, you want to simplify both the left side and right side of the equation. On the left side, we have unlike terms, so we're going to leave them. On the right side, we have unlike terms, so we are also going to leave them. We want to solve for x. In other words, we want to isolate x. However, there are terms with x on both sides of the equation. So either we're going to have to move them all to the left or all to the right. I'm going to move them all to the left. So to move 3x to the left, I'm going to have to subtract 3x from both sides of the equation. On the left side of the equation, the negative 3 stays the same. Plus 2x subtract 3x is negative 1x. However, I do not write the 1 in. 3x subtract 3x cancels out, and the negative 4 stays exactly the same. Remember, you want to isolate x. However, x is stuck with a multiply by negative 1 and a subtract 3. You need to do the opposite of BEDMAS. So you need to deal with addition and subtraction before multiplication and division, which means I'm going to get rid of the subtract 3 by adding 3 to both sides of the equation. So negative 3 plus 3 cancels out, which leaves me with just negative x, and negative 4 plus 3 is equal to negative 1. This is still stuck with a multiply by negative 1, which means I'm going to have to divide both sides of the equation by negative 1. Negative 1's cancel out, which leaves me with just x, and negative 1 divided by negative 1 is positive 1. However, we're not done yet. We need to check to see if x equals 1 is correct, which means we're going to have to do a left side equals right side check. The left side of the equation is equal to negative 3 plus 2x, and the right side of the equation is equal to 3x subtract 4. So I'm going to substitute in x is equal to 1, which means I'm going to replace the variable of x with 1 in brackets. Evaluating these expressions, you need to follow BEDMAS. So that means you're going to be doing multiplication before any addition or subtraction. So positive 2 times 1 is positive 2, and positive 3 times 1 is positive 3. Negative 3 plus 2 is negative 1, and 3 subtract 4 is negative 1. As you can see, the left side is equal to the right side. So since the left side is equal to the right side, therefore x is equal to 1 is correct.